Uh, in today's class, dear students, in today's class we will start the lecture number 8 on propositional logic. So last time I discussed that we will study two logic languages, the propositional logic and the predicate logic. So they will be the chapter 8 and 9 for this course. So propositional logic is the first one. And remember what we are doing until now. So you should be clear about the big picture. So the big picture over here is that we started with the knowledge representation in the lecture 7, and we discussed over there that the information that is coming to us, we can use that information to solve the problems if, and for solving we use the search methods, but we can solve those problems if we have a mission. And when we are able to store it, then there is second thing that comes is we should be able to do some sort of inference or reasoning on that information. So in the Wumpus example, you saw that if the cells if the cell is getting a smell, that is the it is if one cell has a feeling of bad smell and the breeze good smell at the same time, it means the adjacent one has nothing. So we saw it over there quite clearly that we can have such inferences. I gave many other examples in mathematics also. I gave the example that if x is equal to if x is greater than 100 and y is greater than x and z is even greater than y, then it means that y will be greater than 101 and z will be greater than 102, for all of them being integers. So we have discussed these things many times. So here we would like to discuss these things more clearly. Again, we have two purposes. We want to represent knowledge and we want to infer or to produce new information from the given facts. So for this we will study the first language, which is called propositional logic. It is simple one and it has got some drawbacks or bad points. So we will see what they are. So it is propositional logic we study over here, and in this logic what the user do is that in this language users will define some symbols. So symbol is like a variable in a programming language. So you have, for example, P or Q. So anything that is a symbol like this. So you define any variable. Normally the symbols we define are in normal cases they are the alphabets or capital letters in English. So user will define those symbols, and then user will also define the meaning of those symbols. For example, what is P? What is the meaning of P? What is the meaning of Q? Those meaning are also called as semantics. So user will also define the semantics for each of these symbols. For example, user says that P is it means it's hot. So whenever P value is true, it means it is hot. The sensor is receiving, the sensor that is feeling the temperature, it gives us the value it is hot. Q means it is humid. Humid means, you can check on the net, humid means when the air has more moisture, when there is more water content in the air. So humidity normally it is more humid in the areas that are near the sea. So humidity normally also means when it is hot and when there is humid, it means you will feel more hotter, you will feel more sweating. For example, you go to any port city, Muscat, Sohar, in the summer, you will feel more sweating over there as compared to other areas, dry areas. So Q means it is humid, and R is another variable or symbol which means over here we define the meaning, it means it is raining. So these are the three symbols we define. So based on these three symbols, then what we do is that we define the sentence. So sentence, we also call it sometimes as formula. It is defined as a symbol. So one symbol can be a sentence. So for example, I write over here P. So P can be uh, a sentence itself alone. So alone it is a sentence. When I write P itself, it automatically means that P is true. So when I write P, it means that P is the meaning of P was P means it is hot. So when I write this sentence, it means it is hot enough. Only writing P, that means it's a complete sentence. Just like in English, it has a complete meaning. It does not need anything else to complete the meaning. There are more meanings that I can create. I can write, for example, not P. Sometimes we write it with this symbol. Sometimes they are writing it with another symbol. So many symbols are used, but prefer this one. So not P means opposite of whatever is the meaning. So not P over here will mean it is not hot. Okay. So you can use this not operator if you want. So these operators you will be seeing over here, they are the same operator that you study in your logic design course, digital logic design. Same course, same symbols you will see, they are the logical operators. So this is the not symbol. Then you can also create, so one simple symbol can be a sentence. Simple symbol with a not operator, it can be a sentence. Or you can combine two symbols, for example S and T, you can combine them to make another sentence. And this time you can combine them with some operators. So the operators we can use are and operator and or operator. I think this is or, yeah. So yeah, this one is or and this one is and. Okay, or and. There are two more. So basically this language has only four operators. Or, and, this one over here is called implies. So the names are given over here in sequence. Or, and, implies. How it is used we will see in the future. Implies is this one. Okay, and the final one is if and only if or equivalence, this one. What does these symbols mean? We will discuss it. So you can combine them many times. So finite number of combination of these. You can use them many times to make a complex sentence. So for example, you can over here create a sentence P and Q. What it will mean? P and Q. So I think it will come next. Yeah, here it is. So here are the examples of propositional logic sentences. So there is a sentence I create over here. You can use the brackets also. So here it is P and Q. So what does it mean P and Q? P and Q says it is hot and humid. Okay. So hot and humid at the same time, both are true. And implies that I discussed previously, implies is the same thing as you see in your programming languages, you use if statement. So if this is true, if true, the implies says then. Implies is the then part. Then do this. So if it is hot and humid, then. So same then as you see in the programming, if statements. If it is hot and humid, then it is raining. So implies means that it means. Implies itself is same as it means or then. So implies same as then or it means. Clear? Similarly, you can write other sentences. For example, Q implies P. If it is humid, then it will be hot. So these are some of the symbols. Only 5 symbols are there in this language that we will use to create different types of sentences. Okay. And finally, you can write only one symbol to represent one sentence. For example, you can say it is humid. That's enough. Okay. So these are the examples of this language. So basically this language has got symbol, meaning of the symbol, which is called semantics, and a sentence that is created using those symbols. Here is another example. This time the propositional symbols we define. So any problem that is used, it will have its own set of definitions. So any problem, and for that purpose, for your exam purpose also, these symbols will be given to you in the exam. You only have to you will be given the symbols and also the meaning of the symbols, for example, and you have to use them in the sentences. Or the opposite case will be, you are given some sentence or some question or some English expression and you have to create the sentence. We will see the examples, they will come. So here is the sentence. This is not a minus, be careful. This is only a bullet, same as above. So first symbol is B. B is representing, the meaning of B is there is burglary occurring. Burglary means some theft. So it's another word, you can check on Google. Theft. Someone breaks into the house and the house alarm detects it that someone broke the window or door. So theft is occurring, so there is an alarm B. Okay. There is another symbol that represents E. It represents earthquake. Okay. Then there is another symbol A that represents the alarm. It goes off. So burglary occurring is an event and alarm goes off is another event. So mostly you will see that these symbols, they represent some sort of event in the life. In some problem they represent event. So for example, over there they represent some behavior, some adjective, but here they represent events. So alarm going off is one event, and then John and Mary are two people, maybe the owners of the house. They call on the phone. Those are represented by capital M and capital J. Okay. So these values can be true or false, but when you write it in the sentence, for example, in the sentence you write B, it means it is true. That's why you are writing it. If it is not written, then it will mean it is false. So values of them, normally any of these variables or symbols, sorry, so always use the word symbol. Any of these symbols, they can have three values. They can have either true or false or unknown value. Also in the language you can use two constants that are allowed to you. So in the programming also you can use constants which are numbers. For example, in your C++ programming you can write, for example, y equal to x plus 3. So 3 is a constant. Here there are two constants that are allowed to you, because remember, every variable over here in this language, so this is an interesting but a very different language from normal programming. Here you have only true and false values for all the symbols. Symbols can be true or false. So that's why we can only have two constants that are possible, that you can use in your sentences, true or false. So in this language, be very careful. There is no meaning of any number, and also there is no such thing as plus in this language. In this language we have only 5 symbols. This language is different from your normal programming languages like Java, like C++ or Python. So here it is. The symbols that we can use in this language are not, and, or, what was it, implies, and if and only if equivalent. These are the 5 symbols only in this language, 5 operators, not symbols, sorry, operators. So for this example, we want to create some sentences. So we want to form some logical sentences using these three things. Propositional symbols, first one, constants. What are logical constants? Yes, true or false, two constants. And then you are also allowed the 5 logical operators. Operators are those things: not, and, or, implies, and equivalent. So using these three things you are given in the exam. For example, you have to make the sentences which are given to you. For example, in the exam you can be given a sentence like this: alarm sets off whenever the earthquake or burglary occurs. Okay, now think over it, and don't try to look at the answers. Just focus. You can understand this sentence and you can translate it or not. So here it is the meaning, the sentence written in propositional logic. So E was for the alarm. Go back to check the meaning. So E was for the earthquake. B was for the alarm. So if you want to, B was for the burglary. Sorry, alarm is A. So alarm sets off. So alarm will trigger or turn on whenever there is a theft, burglary, or the earthquake occurring. So there is an or coming over here. So the or is directly translated over here like this. E or B, that implies A. Clear? So it is always I tell you that this implies is same as the one that is in your if statement. So if this condition is true, then A will trigger. That is the meaning over here. Then the next sentence: both John and Mary call when the alarm sets off. So when the alarm sets off, that is the starting point. That's the trigger. That's the starting event. So the starting event occurs. Then in that case, A implies J and M, John and Mary. So here in the English you have and the same and comes over here in the operator. So be careful. So this was the second sentence. I hope it's very simple, very clear. I don't know if something is not clear. So if it's not clear, please ask me. I will repeat it. Now this thing is very important over here. It is the equivalence. Equivalence, or if and only if, or biconditional. There are many names. So sentence can be like this: John calls if and only if Mary calls. Now what does it means? That it means if and only if means equivalence. It means that both the events, they are 100% same. When John calls, Mary must call. But when Mary does not call, or John does not call, Mary will also not call. They are 100% same. Either both of them will call or both of them will not call. It cannot happen then that only Mary calls, John does not call, or only John calls, Mary does not call. That is not allowed. It is not possible for this operator. So if it is happening that Mary calls and John does not call, then at least for this sentence is wrong. It's false. It is false. In that case, this sentence will be false. That event can occur. Any event can occur in nature. But that event, for this sentence, it will be wrong. It is false. Finally, when John calls, Mary does not call, that will be represented by this thing. The opposite case. If one calls and the other does not call, it will be written like this. So to judge the meaning of these sentences, we will discuss another thing that comes next, which will be the truth table. So propositional logic is the first one we study. It is the simplest of all the logic languages, and it has got three things we will discuss. It has a syntax. Syntax means what is the grammar of sentence. So sentences, they are created with symbols, constants, and operators. Three things. So that is the syntax. Then comes the meaning of the sentence. How we will define the meaning? Meaning of individual symbols, we define it. For example, S and T, you define the meaning. What does it mean? Okay. But what is the meaning of the whole sentence? That we will discuss how we represent it. The meaning of the whole sentence is given by something that will come in the future. You already have studied it in logic design. It's called meaning is defined using truth tables. Clear? So two thing, and the last thing we will discuss, it will come, it is the entailment. It is same thing as you saw in the last chapter. It is inference. So the syntax first. So syntax of the propositional logic, it defines the allowable sentences. So allowable sentences are of two types. Either sentences can be very basic, we call them atomic sentences, or sentences can be complex. Okay. The basic sentences are very short, to the point. So any symbol itself is a sentence. So any symbol you define, P, Q, S or B, M, all these are symbols. Similarly, constants are also atomic sentences, true or false. Okay. The complex sentences, they are constructed from the simpler sentences. So they are constructed using these simple sentences that we saw already earlier. The atomic sentences. Simpler means atomic. Using the logic connectives. Logic connectives are those operators you have seen previously. And also one parenthesis is allowed in this language. Using the operators, previously you saw the 5 operators: not, and, or, implies, and equivalents. And the brackets are also allowed. So these are the 5 logical operators we see in this language. Implication is, what does it mean? Implication means that implication is also called as conditional. Implies also called as conditional. Clear? So conditional, why we call it conditional? Because if A is true, then the condition is satisfied, then we will check if B is true. So the first part of this sentence, always it will have two parts, two symbols, always, first and second. The first one is called as premise or antecedent, and the second one is called as conclusion or consequent. That comes later on, it's the conclusion. Just like you write an essay or a research paper, the last thing in the research paper is conclusion. Conclusion means the result, the summary. So here also B is the conclusion, A is the premise or antecedent. You can also call the implication as a rule or if-then statement. It is same as if-then statement in programming languages. Clear? And the final operator, logical operator, is the bidirectional condition, biconditional, or the equivalence. Equivalence means that both sides, they are equal, 100%. Now there is a one important difference between these two. What is different between implication and the equivalence? In the case of implication, you check the output only when the input is true. So if A is true, if A is false, you don't care about B. When A is true, then you check the B is true also. When A is true and B is false, that is a wrong sentence according to this one. For this sentence, this model is not correct. So remember the model we studied in the last one. We said the input combination that makes the sentence correct. Okay. So for this sentence, this model is correct. But A is false, at that time we don't care. B is false or B is true, we don't care. Both of them are correct. So in this case, these three models, they represent this sentence. The fourth one does not. It's not allowed. Whereas if it was A equivalent to B, like this, then there are only two solutions possible, two models are possible. Either both of them are false or both of them are true, 100%. So here it is, the same things are repeated over here. The logical operators, we can use them with the constants. So logical constants are these two, symbols, and symbols can be negated. Symbols are also sometimes called as literals, and sentence can be simple sentence, not S, um, or it can be complex sentences over here, and or implies or equivalence. Clear? Now one more thing that we will study over here is called the BNF, Backus-Naur form. I don't know, but mostly I think as my experience in the past semesters, students don't know over here. Backus-Naur form is a representation. You can check it on the internet. It is a representation. It is a special type of language that students study in the compiler related courses. So Backus-Naur form, it provides grammar for the sentence. Normally it is used to write the how some programming language, how language works. Programming language works. So let's say you have a programming language C++. So how the constructs in the language, if statement or for statement, all these, how they will work, what are the rules, what are the variables you can use in this language, all are defined using this language, Backus-Naur form. So it is the grammar of sentences in any language, not only propositional language. So in this language, we define the rules. So let me check, I give you an example. So let's go over here and you search, for example, C++ Backus-Naur form. Okay, BNF. In short, it's also called as BNF. So those are people who are especially working with the compilers, to make some programs that can compile C++ code, that can run C++ code. So they are mostly very interested in this thing, Backus-Naur form. So here you will see in this language, for example, if I want to check the variables, let me find it. No, it's not given. So these are the operators that are allowed in this language, the unary operators. Then there will be other operators, binary operators. These are the data types that are allowed in this language. So data types are given over here. So statement can be a labeled statement. So labeled statement, for example, it can be like this. This is the, I think, for the switch case. So these are the digits that are allowed in this language. These are all the operators that are allowed in the language. Let me check some other. Yeah, this one is more clear. So here it is given, for example, type dash specifier. So it shows over here what types are allowed in this language. So the types allowed, for example, is it can be void, means nothing, or a character, or a short, or integer, or long, or float. These are all the things that are allowed in this language. So there is an or symbol. Void, this pipe over here, this line over here, it means or character or short. Any of the value can be used out of these values. So this is how the language is defined, and there are so many things in this language. So many things in this language. It will show you how you can use the language, and someone who is using the language. So for example, here if you want to use the equal to operator, assignment operator, how you can use simple equal to or multiply equal to or divide equal to, all these are allowed. So this is how the language is defined itself. So here is the Baker-Snore form which is given for this propositional logic, and it's very simple. So how we read it? Sentence. It can be atomic sentence, or it can be atomic sentence or a complex sentence. Now the meaning of the things will be defined step by step. What does atomic sentence mean? We don't know. We will discuss further. So atomic sentence, it means either it's a true symbol or a false symbol, or it's a constant true or false, or it is a symbol. What is symbol? It's not defined here. It will come next in another sentence. So these things are nested. The meaning are nested. So it will come somewhere else. So symbols, it will contain all the alphabets or all the digits or all the letters that are allowed. I will write them over here, not only PQR. It will be, for example, all of them, A, B, C, starting from A, B, C, anywhere. All the things that will be allowed, I have to write it over here. Okay. So complex sentence, it is maybe a not of a sentence, same thing you have saw previously, or it can be the end of two sentences, or it can be or of two sentences, or implies or equivalence. So this is the complete Baker-Snore form for this type of language, which is a very simple language. So here is another thing that we see normally in the languages, which is important, is the precedence. Precedence means, what does precedence mean? Precedence means priority. So you may have seen this typical problem in mathematics. People used to see this trick. 2 plus 2 multiplied by 2 equal to what? Okay, all of you, or hopefully remember this from your college, that multiply is higher priority as compared to add. So if you want to solve this equation, the answer 6 is wrong. Okay, so if you try to do, for example, 6 is correct. The answer, if you try to do add first of all, because maybe you think that started from the left side. So 2 plus 2, 4. 4 into 2 is 8. 8 is the wrong answer. Whereas the correct answer over here will be 6. Because you will do this operation first. It has high priority, and then you will do add. So 2 into 2, 4. 4 plus 2 is 6. That will be the correct answer. So in this language also there is priority sequence. So brackets, they have the highest priority. If something comes in bracket, you will solve it first. Then there is the not symbol, that has high priority. So if something is written like this, not P and Q, it means not is attached to the P. You cannot apply the P and Q and then apply the not. If you want to do something, the not of whole P and Q, you will put a bracket. Bracket will change the order sequence. I hope these things are clear. You have seen these things many times in your logic design course also. Same thing over here. Then there is the implies and the equivalence operators. They have the lesser priority as compared to and or. So if you have a not P and Q implies R, means that first of all finish this evaluation, check what does it mean, and then you will use the implies operator to go to the next other side. Clear? So sometimes the symbols or operators, the operators are same, then there is no priority, you don't need any parenthesis. So here it is, A or B or C, you don't need any bracket. Even if you put the bracket, it has the same meaning. There is no difference. You choose any order, it will not make any difference. Clear? Then over here, there is another example. Just think over it. What do you think about this one? A implies B implies C. What do you think? We need a bracket parenthesis or no? So this is a question. I leave it to you. If you can answer it in the group, then I will also know that if you people are listening to me carefully or not, you are skipping the lectures. So just if you read this, go to the group and give me the answer to this thing in the group. Some more examples. So these are the symbols and the meaning of the symbols. Then over here I have got one sentence. So this is the same as you saw previously. Another one you see over here, Q implies P, it is humid. If it is humid, it's hot. I think it came before. All this example came before. So this was till now the syntax that we defined. Syntax is more of formally, more clearly defined using the BNF, Baker-Snor form. Okay. Then comes the semantic. Semantics means meaning. The meaning of the individual variables or symbols, I define it. What about the meaning of the whole sentence? So sentence can be very complex. How I can be sure if there is a sentence P and Q or not Q, there is a very long sentence. How we will be sure about the meaning? What is the exact meaning of this sentence? So the meaning of long sentences or short sentences, it is extracted using truth tables. So propositional logic sentence, normally one sentence, so not normally, always one sentence in propositional logic, any sentence, it will have only one result. Only one result for one sentence. Either this sentence is true or false. Or sometimes you can say I don't know. Okay. So a model is basically set to true or false values for all the propositional symbols, and then you try to check the whole sentence. What does what it means, the whole sentence. Clear? So semantic basically, it defines the rules for determining the truth for the sentence with respect to the particular model. I give you the example and then we come back here. So here you see the example. I don't like this one. For your exam, please always start with the false, false, not the true, true. This one. So should I say that you cancel that? Yeah, it's better if you cancel it. This one. Only follow one standard. The standard is this one. Start with the false, 0, 0, 0, 1. So it is over here. 0 is false, 1 is true. So 0, 1, 0, 1. Like in your logic design. So if I want to define a complex sentence, let's say the sentence is this one. Okay. I will always start with the basic symbols. I will write them down. For example, my symbols are P and Q. Okay. And from this P and Q, I will write down all the possible values for these two symbols. So a symbol is like a variable. In this case, it can have two values. Either it is false or it is true. So I will write down all the possible combinations. For two variables, I will have 4 possibilities. So either both of them are false or Q is true or P is true or both of them are true. 4 possibilities are there. If I have 3 variables P, Q and R, I can have 8 combination of values possible. If I have n variables, I can have total 2 power n different combinations. So here you have 4 combinations. Like this I can have 2 power n combinations. So what does it mean if it is if one sentence is like not P? So not P is just the opposite of P. So P is false, false, true, true. It is true, true, false, false. P and Q, it is same as in your logic design course. If you not remember, just go and refresh it little bit. It is 0, 0, 0 and 1. P or Q, it is 0, the first one, and the others are 1, 1, 1. P implies Q, it means that you have the, when the P is, now this one is a little bit tricky, be careful, okay. The implies relation, it means that whenever P is true, then Q should be true, okay. So P is true when P is true, Q is true, it is this case. When P is true and Q is false, it means my sentence became false. Now this is a bad model. This is a bad model for my sentence. Whereas when P is false, I don't care. I don't even evaluate this sentence. I will stop. When P is false, I don't check Q. Okay. So it's given over here like this. Both of them are true. And equivalence, as we discussed before, P and Q should be 100% same. So P and Q are same in the first model and the last model. Here you see another example, a complex sentence. Those were the 5 basic operators used. Here I have complex sentence, this one. So for this I write down all the possible values of P and H. And I tried then to find out the individual values before I can calculate the complex sentence. So first I find out P or H. So P or H is this. It is same thing as 0, 1, 1, 1. Then I try to find out P or H and with not H. So for this, in your exam, make sure that you first calculate not H. If you don't calculate not H, you lose marks, and also it's very dangerous if you try to do it directly. So not H over here will be true, false, true, false. Clear? So I will do the AND of not H, these two. I will do the AND operator. So I will do the AND operator, I will get this thing over here. So what it will be the AND? True and false will be false. False and true will be false, and true will be true, and last one will be false. So only one sentence, only one model is true. All other models are false for this sentence. So remember, each entry over here, it is called a model. That's what we studied in the last chapter. Each entry is a model. Only those are the models that are considered the model for this sentence where this sentence is true. So for this sentence, all of them are true. So this sentence has all these models. Whereas for this sentence, only first, second and fourth model are correct. Third one is not the model for this sentence. Model means the combination of input values that you can use. Clear? So here is another example, a small quiz. Like this you can expect in the exam also. So meaning of the sentence is given to you, meaning of the symbol, sorry. It is given to you. O is a symbol which means 5 is an odd number. E is another symbol which means 5 is an even number. Okay, this is the meaning I have given. It does not mean that I have said that this is always true. So it can be false depending on the real situation. What do you think? 5 is even or odd? So 5 is odd. So it means that O will be always true, whereas E will be always false. So these are just like constants because of these values. So the meaning is such that it will always be false, E will always be false, and O will always be true. Okay. Next is there are two more symbols I define. P, Paris is the capital of France, whereas M, Moscow is the capital of France. Now all of us know that this sentence is true, this symbol is true, but the last symbol, it is false. Okay. Now based on these facts, now the meaning over here is given as a trick. This is tricky, but in practice you will be given clear meaning, very clear. Here it is given as a trick. So O is given to you. O implies P. O is true. So if it is true, I will check that P is also true. So P is also true, yes. So it means overall my sentence is true. Clear? What about the other? E implies M. Now E means 5 is even, which is false. So when it is false, now this is the tricky part. When it is false, I will not check what is M. I don't care. So if it is false, the first part, I don't care, and I say that this sentence is also true. Now this is tricky, very tricky. Be careful. If E is false, I don't check the second part of the sentence. Okay. Here are some more examples. Normally I leave it to the students. So pause it over here and try. Which one is your, wait, so these are the two. Okay, I will discuss these two in the next class. Just check if you can do it, then I will give you the answers, and I will also give you an assignment for this, which is very important to solve for you people. So make sure that you do it yourself, give it a try, and then we will discuss these two, this one also. Okay, then I will discuss in the next class. So propositional logic, the last thing that is important for this language is the entailment. So entailment over here, it means that it is the same as the inference you saw in the last chapter. So entailment means the existing sentence, it can be used to create it. Can it be used to infer a new sentence or not? So if you remember, we saw this example in the last chapter. Knowledge base, it will entail an alpha if they are true in the same model all the time. So let's say for A, B and C we have, so you all know that for A, B, C we have three variables. We have these combinations of values possible. These are the values of A, B and C that are possible, all possible combinations. So if I have three variables, I will have 8 values, 8 combinations possible. So for these values, the knowledge base has already got a sentence. Okay, this is the sentence given: A or C whole and with B or not C. This is the sentence given. This knowledge base sentence, it is true for these values. 4 values, it is true. 4 models, it is true. Now what does inference mean? Inference means that I can say that knowledge base agrees with the new sentence. New sentence can be made with part of the knowledge base if the alpha is true for these positions where knowledge base is already true. I will check only these places. I don't care about the other places. Other places may be true or false, I don't care. Okay. So when it is the case, which is true over here, in this case it is true. So I will say that knowledge base entails alpha. Clear? So that is what is happening over here. So we check all the possible models where alpha must be true whenever the knowledge base is true. So whenever knowledge base is true, there are 4 cases. I will check for alpha if alpha is also true in that case. Clear? So alpha is the sentence over here. It is A or B. You can check its value. Its value is true in these cases. Except the first 2, it is true for all others. Whereas the knowledge base has a complex sentence having 2 parts. So when it is true, we say that knowledge base entails alpha. To check the inference relationship, we normally do a process. It is called as model checking. So model checking is a process where we take all the values of knowledge base where it is true and we check if the alpha is true. All these steps are followed and normally this will take a lot of time. If you have a big example, this is a very small example, you have only 3 variables. Just imagine you have 100 variables. What will happen then? So in that case, when you want to check a lot of examples, it will have an exponential time complexity. So time taken will be too much when you create a truth table and try to find out the model complexity. If you try to find out, the model complexity will be too much when you try to find out one by one all the models, they agree with the new sentence or not. So inference over here, it's not good, this method. It will take too much time. So this method, but in general, it is called model checking because you go one by one and check all those models. Only those models you will check where the knowledge base is true. So one by one you go and check all of them. That's why we call this technique model checking. Model checking is a very common technique and there are many softwares available where it can perform model checking on the systems. So applications of inference, they are used to find out new sentences from the old sentence, new valid sentence. Legitimate means valid, sound or valid sentences. And it is also used inference to prove that a sequence of inference you can use, for example, to prove something, that if the knowledge base and alpha, they have a relation. So we can use inference as rules on standard search algorithms. We can use them also as in our search process. Remember, when we are discussing the sentences, there are 3 types of sentences. So when a sentence, it can be valid. Valid means that it is true in all the models. True always. All models. So a sentence is valid if it is true in all the models. Clear? So example for this sentence can be, for example, A or not A. So A, what is the value of A possible? Let's say A is a single variable, single symbol. It can be true or false. What will be not A? So not A written like this, it will be true, false. And if I write it like this, A and no, A or not A, sorry, A or not A. So when you take the or, it will be always true. So such a sentence which is always true for all possible models. So models depend on the number of variables. So such a sentence, it is called as valid sentence. So simple example can be valid sentence is only a constant true. True is always true. Okay, we can't change. So here it is, all of them, they are always true. All of them, you can just judge. Whereas the opposite of valid is called unsatisfiable. Unsatisfiable is always, always false. So A and the opposite one, A and not A. Because there is the and relation, so F false and true will be false. True and false will also be false. It will be always false. So such a model, such a sentence which is false for all the possible models or for all the possible input values, we call it unsatisfiable. And in between these two extremes, the extreme is valid and unsatisfiable. In between these two, there is a satisfiable sentence which is true for some models and false for some models, which is, you can say, 99% of the time you have such models. You have such sentences. Sentences are such that they are true for some cases and false for other cases. Clear? So you can also say that the validity of a sentence, it is connected to the inference by this theorem. It's a very simple theorem which says that if knowledge base and alpha, they will entail each other. So alpha will entail the knowledge base if they have commonalities. If they are common or and part, it is valid. Both of them, they have the models. Whatever the models are for knowledge base, they are all the models for alpha also. So all the models that the knowledge base has, all of them are also true for alpha. That's the meaning. Whereas in the opposite case, in the unsatisfiable sentences, we say that knowledge base and the opposite of alpha, the opposite of the sentence alpha, they have nothing in common. They are unsatisfiable. For example, knowledge base is true in sentence number 1 and not alpha should, so alpha is also true for number 1 sentence. Not alpha will be not true in the number 1 sentence. Maybe it's true in number 2 sentence. Okay. So in that case, we say that they are unsatisfiable. Overall, the end of these two sentences, it will have nothing in common. They are false everywhere. That is the meaning of this sentence. They are false everywhere. Whereas the meaning of this sentence is they are true everywhere. So this was the definition for three things: valid, satisfiable, unsatisfiable. We see over here. So here is a small quiz. Valid sentence, it is true in every possible model for every combination of values of symbols. So this is the definition. We will see the quiz next coming. Satisfiable sentence is the one that is true for some models and false for others. So here is a sentence given. Now this is another type of exam questions. You will definitely get one such question. Okay, you will be given the sentences and you will be asked that these sentences are valid, satisfiable or unsatisfiable. So if most of the cases sentences are satisfiable, but it depends on the problem. But if there is for example a student who is so weak that she or he does not know anything about the propositional logic, so remember 99% of the sentences are satisfiable. So if she knows nothing, then at least she should make a guess of satisfiable. This is just a joke. But remember, practically, you have to solve it to know exactly for your exam. So if there is a P or not P, so when you take the opposite values and make it OR, so if it is false, the other one will be true. So it will be overall always true. So it's a valid. Okay. P and not P, it will be unsatisfiable. Unsatisfiable. Opposite. Clear? What about the third and fourth and fifth? So here I will show you. Where can I? So this one also I will show you. If you can do it yourself, it's good. Else I will show you in the next class. I will put the next lecture and over there I will explain it to you. All these three. First you have to try yourself. Remember in this example below, there are some symbols given. Now this is a bad example. Symbols are normally only letters, capital letters, but it's possible. It's not something forbidden. Still you can use these variables. So let's say you have the symbol food, party, drinks. So can these three, so these are the three values. You can suppose any, these are the three symbols, you can suppose any value, just like you do for other cases. So if you have three variables, what will be the set of values? Definitely same 8 combinations. So for example, you have food, party and drinks. Okay. So for this you will create the same sentence. So false, 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 true. All those combinations you will create. And as in logic design, true, true, true will be the last. So you have to check if this sentence it is true, it's valid, satisfiable or unsatisfiable. This you have to explain. Clear? In the next class I will explain I will give the solution to these things. If you do it successfully, as soon as you do, post a message in the group. So we saw today this propositional logic. This is a mistake. So this is propositional, not predicate. Predicate is the next one coming. Okay, predicate will be the next chapter. So propositional logic, it's a declarative language. So remember what is declarative. If you don't remember, go to chapter 7 and revise it. There are two types of programming styles, declarative or procedural. Procedural languages are the normal like Python, where you write the code, for example, and code runs in sequence. A equal to 2, B equal to 3, and then you do A plus B. C equal to A plus B. Okay, but that is procedural. But in declarative, you write in sentences and each sentence is independent. It does not depend on others. Another example of declarative language is the mathematics. Mathematics, normally we write formulas which can be independent of each other. So here it is propositional logic is a declarative language. Each sentence is evaluated separately. Propositional logic is compositional, means it is composed of parts. So each sentence is made up of small parts which are symbols, constants or operators. So you define the meaning of the symbols. For example, you have a symbol like this. It's possible you can define a symbol like this also, B1.1 and P.1.1. So it has two symbols. You will be the one who will provide the meaning of these two symbols. Overall, this language is good and it provides a very good or efficient manner for inference, efficient mechanism for inference. It's a good method that provides us help to do some sort of inference. So the Wumpus example, for example, you can do some sort of inference from this over here. So it has a very strong and efficient mechanism for inference, and also for each sentence you can determine the validity and the satisfiability of the sentence. Normally the language it has got, so here it's again wrong, change it. So meaning is given, the propositional logic it is context independent. Context means the environment. Okay, I always give a simple example that natural languages like Arabic or English, they always have a context. So okay, for example, I am standing somewhere and I say in anger, go away. That means, or I say only go in anger. So the anger has some meaning itself, or the tone of the voice has meaning. If I say loudly go, that has a meaning different. If I say politely go, even if I don't use the word please, I say go, that has a different meaning. So the anger in the voice, or the high tone of the voice or low tone of the voice, that has a meaning itself. So normally the natural languages, English or Arabic, they normally have a context. Context means the environment. Okay, there is an environment related to that sentence that you say, that speech you give. You say something in a good manner, or in a bad manner, that will change the meaning of the sentence. A sentence, same sentence, you express in two different tones will have a different meaning. So meaning of sentence in natural language, it depends on context, the environment, on other things, not only on the language. But the good thing about propositional logic is it is context independent, free of context. You say P implies Q. You can say it politely or you say it in anger. It has same meaning. So any type of emotion does not have any effect on this sentence in this language. Now this is very important thing, very, very important. Languages, especially these languages that are representing the data, the knowledge related to AI, it should not depend on any type of context or surrounding information. Another thing that is a bad point for propositional logic, that it has a limited power. Its power is less. It is not as powerful as a natural language. Natural language we can say express many things. One example you see over here, if you remember from the Wumpus world, in the Wumpus we defined over there, in English we defined pits, they cause breeze in adjacent cells or squares. The squares that or cells that are next to the pit, they will have a good smell. Now this thing you cannot write it in propositional logic. It's not easy to write it in propositional logic. Okay, so in propositional logic you will have to define the cell first. You will define cell C11, and you can only define that the cell that has a pit, for example cell C11 and pit P, together they imply that there is a good smell, breeze. B is the breeze. Let's say, so you will always define these symbols. B, capital B means breeze, P means the pit, the hole, and the C11 means the cell. So C11 cell is causing the, if it has a pit, then its neighboring cell has a breeze. So you will over here also write the neighboring cell name, which is maybe C12. Okay, so it's not easy to define these things in this language. This language does not have that much power as the English language has. So in this propositional logic you can only handle true and false values. Okay, you have only two types of values. And also you cannot talk about the objects and the properties of the objects. For example, the size of a ball, the weight of a ball, or the color of a ball, you cannot define. So there are many things you cannot define in this language. It is not possible to have things with different values. Only two values are possible, and you cannot talk about objects with properties. And also you cannot talk about the relation between objects. So for example, one person is Ali and other person is Ahmed. So you cannot define over here Ali is related to Ahmed, or Ali is the son of Ahmed, or etc. You cannot explain it. Also in this language, propositional logic, you don't have any capability to handle stochastic behavior. If I say that, for example, P implies Q, that is okay. But if I say P has a 20% chance, rain, or hot weather has 20% chance, you cannot explain here. This you don't study over here even till now. You don't study this thing in artificial intelligence. This is a separate topic we don't cover in this course. But this uncertainty is not covered over here also in propositional logic. You cannot talk about many things in this language. Okay, one sentence, I think it will come. So yeah, this example. Again, this is propositional, sorry. Okay, so let's say this is an example. You want to say that for the Wumpus world, you have 16 locations. Remember, there were 16 cells, 4 by 4 grid. So 16 locations on the Wumpus world. You want to say that all of them are free of pit. There are no pits. So how you will define it? You cannot define it. You need to create an AND of all the 16 cells, and then you will say no pit. For example, you will write a sentence like this: C11 and C12 and all of them. Last one will be maybe C44, and you will say implies no pit. And this is a big problem, because let's say now you have only 16 cells. Let's say you have 1000 cells. What will happen? Can you write a big sentence with 1000 cells like this? So this is the weakness of this language. You cannot do it over here. For this purpose, we will go to the next chapter. In next chapter, we will cover the next language, which is the first order logic language, also called as predicate logic. So we will go over there, we will discuss that. That language over there, we can describe the objects. For example, the age of a person. Here we don't have any such thing. Here we can have symbols only true or false. Over there we can have many things. For example, age of a person, you can say, for example, it is 30. And also over there are special symbols that allow you to talk about many things at a time. So this is not a problem over there. This talking about all the cells at the same time. So this was it from this chapter. We cover only till this point. We don't go into other details. And then we will move to the next. We will see the first order logic. I hope it is clear. All the things we have done, go through these things again and again. If you have any question. Here we have discussed the properties of the logic, propositional logic, the good and the bad points. It has 4 bad points, you can say. It can only handle true false. It cannot talk about objects. It has nothing to explain uncertainty or stochastic behavior, and you cannot talk about many things at the same time. Out of these 4 drawbacks or bad points, only 2 of them are resolved by first order logic. First order logic, you can use it to talk about many things. You can use it to talk about objects, and you can use it to talk about many events or many things at the same time. Okay, so this is it, and go through it, and this is like your small assignment. Normally in the class I ask the students to solve it in the class and we discuss, but here you can try it yourself. I give you the time, and then we will do it together. I will show you in the next lecture. At least first one, you know, this first one is valid and the second one is unsatisfiable. Others you have to solve it to check. So always when you want to solve the validity or satisfiable, unsatisfiable, you have to create the complete truth table. And please don't take these questions easy. There is a confirm exam question that comes, and always every exam I see many students making it wrong, doing it wrong. Okay, so I hope it's done, it's clear. Any questions, come to the group and ask. This is another one. This one you also have to solve. Sentences are given. For the given input values or for the given models, you have to find the status of the sentence, the output of the sentence. Is it true or false? Always when you are solving, you have to define the intermediate variables on a separate page when you do, or in the exam when you do, you will do it step by step. First of all, you will solve it for P implies Q, then you will solve it for together, then you will solve it for not, no, then you will solve it for the inner part, and then together, step by step you will go for every part of it. Okay, you will not directly write the answer. Writing the answer directly, it is just like you do if you do it in the mathematics. You directly write answer, you will lose marks for the whole procedure. So do this and we will come and discuss in the next class the remaining topics.